Good evening. From the Gail Lemron Auditorium on the campus of Embry-Riddle, welcome to the Embry-Riddle Speaker Series. I'm Marc Bernier, the moderator for tonight's event. Tonight, an interactive and musical event. Following the success of last year's The Mars Experience, tonight the largest planet in our solar system, Jupiter. Welcome to the Jupiter Experience. It'll be the music, pictures, and words of experts, and we'll take your questions throughout this evening about Jupiter. We have a panel that will be assembled briefly. It is our same panel that we had from last year, bringing the experts back. When you have a hit, why disturb it and make sure you have the same people again? I'd like to ask, he's from Flight Ops here at Embry-Riddle. He is the director for tonight's experience, Brian Hergert, who joins me now to talk about the music that we'll have to open tonight's program. Then our interview begins. Brian, what do we have?
Thank you, Mark. So the first song we have is a medley of a suite called The Planets, written by the English composer Gustav Holst in between 1914 and 1916, and it was first debuted in 1920, so we're kind of like in the 100th anniversary of this suite's creation. In total, there are 7 movements within his suite, one for each planet in the solar system, except for Earth, and I guess depending on how you want to look at it, except for Pluto too. That wasn't discovered yet. And then in this particular medley, it's 3 songs. So listen for 3 distinct different themes, and afterwards we'll tell you what each of those are.
Okay. And now the Pep Band performs here tonight in the Embry-Riddle Speaker Series.
So this whole suite, Holst drew his inspiration from the planets based on the astrological significance or action of each of the planets, and not so much the mythology behind the names. And about the music, he said that if any guide is required, the subtitle to each piece will be found significant. So in the medley, you first heard Venus, which was the bringer of peace, and this was a slower tempo song, muted dynamics. The melodies were very similar in the pitches. There weren't great changes in the pitch of the note. And then following that was Mars. That was the 5/4 march, very bold, very foreboding, very intense. And that was for Mars, bringer of war. And then the final two themes, so there were two kind of wrapped into that melody, were Jupiter, the bringer of jollity. And Holst said of this planet that it brings jollity in the ordinary sense and also in the more ceremonial type of rejoicing associated with religions or national festivities. And the chorale in the middle of that song is quite popular in that religious sense, known as the melody Thaxted, and initially adapted by Holst himself. The theme was joined with the English patriotic poem I Vow to Thee, My Country in 1921, so right after the original debut of the planets. It's a very evocative, very pensive melody, and this arrangement was played at the funeral of Winston Churchill, as well as the wedding ceremony and funeral of Diana, Princess of Wales. Holst's planet gained notoriety from some elements that were unique for his time as well. In Neptune, the mystic, you took a chorus of women, put them in a room adjacent to the performing space, and at the end of the song, they would keep singing and you would just slowly close the door. This created a fade out in a live sense and was very novel for the time. And the original composition of Jupiter was written for a full orchestra and had the unique requirement of needing no less than 6 timpani, sometimes 8, and typically speaking, you only have 5 timpani in an orchestra. Since that's 100% more timpani than we have available, our next song is an arrangement of Jupiter for brass band by J. Bocook.
Pep Band. Brian, why don't we share with the people who are going to be watching this on YouTube, and thank you, they'll be back to play us out when we conclude the program. Why don't we give some credit so the folks who are listening on radio and then seeing on YouTube know who these great performers are.
Thank you. As the band returns to their seats, I'll read off the names by each section. In the flutes, we have Megan Dunn, Olivia Kingsbury, and Katie Larson.
Well, I wave to the people, so wave to the camera.
Just raise your hand as I call your name.
There you go.
In the clarinet section, we have Alyssa Ryder and Eric Moreland. In the saxophones, Andrew McNaughton, Brendan Kirkpatrick, Bryce Carlins, and Jackson Smith. In the horns, Sebastian Jones, Haley Larson. In the trumpets, Megan Walker, Christopher Rivera, Jack Gangloff. Trombones, Michaela Wolsing, Caleb Edwards, Carl Morgan, Benjamin Gangloff, and Monique Payton. On tuba, Ty Hall. And in percussion, Brian Schmidt, Sean Reid, and Dylan Krell. Thank you so much for having us.
They'll be back. They'll be back. Good job.
Thank you, sir.
So we'll be back to play us out. We're going to the interview part of our program now, and we'll be taking your questions to the students who have joined us tonight. Thank you very much. How many are getting extra credit? Anybody getting extra credit? Ooh, nice. Good job. The word got around. All right, here we go with our panel. The students know them. For the general public that may not have been here last year, let me introduce them from left to right. Jason Oftenberg is an associate professor of physics and astronomy, and in the undergraduate program as a coordinator, astronomy and astrophysics. I don't know how he gets it all on his business card, but ladies and gentlemen, Jason Oftenberg. Round of applause for him, please. Also on our panel tonight is the assistant professor of astronomy in the Department of Physical Sciences. Ashley Kehoe is here. And my partner on at least now 4 or 5 of these events over the last few years is my trusted friend. He is the chaplain here at Embry-Riddle. He is also an adjunct professor in the Global Conflicts Studies Department. Ladies and gentlemen, the Reverend David Keck is with us tonight. All right, let's get right to it, and we'll go, and pardon me, I'll try to walk this way so that I don't block any of the guests, but let's begin with you, Jason. This is the largest planet in our solar system, and I think you educated me that there are 64 moons around this planet?
That's right, 64 moons. It all started with Galileo in 1609 when he saw the first big 4 of them. That's right.
Okay, is this and a lot of this will be elementary, is this a solid mass planet or is it made up of gas? And Jason, Ashley, feel free to jump in.
Well, Jupiter is one of the gas giants, so it doesn't actually have a solid surface like the terrestrial planets like Earth that you could stand on, but rather it's a gaseous surface, sort of blends in with the atmosphere.
Can everybody hear Ashley, by the way? I'm kind of losing. We're gonna try it this way, and
Okay.
I'm hoping that I'm not throwing you off mic. So it's more of a gaseous situation. Is the planet getting bigger or smaller? Because I think in our pre-game talk we talked about the changing dynamic of this planet. Jason?
Yeah, essentially it's in a way still forming. It's gradually, very slowly, but shrinking in size, contracting, and that leads to it actually converting some of that potential energy it has into radiation. So it actually emits more light than it receives from the sun, or emits more energy than it receives from the sun.
Is it how many planets across?
How many
people looking at the map of the planets? How many across from the sun?
I know if you put it on a scale, it'd be 300 Earths heavy.
Wow.
So it's substantial.
Does it have North and South Pole?
It certainly does. Yes, it spins the same way the Earth does. So east is on the east, just like it is for Earth. They both spin the same direction, but it goes around about every 10 hours, as opposed to 24. So it's a rapid spinner.
Maybe I've watched too much science fiction on television, but Ashley, do we have any worry that this planet might crash into us one day, or a part of it break off and crash into us anyway?
No, we're not worried that Jupiter's going to crash into us, but there is actually some theories on the formation of the solar system, and that Jupiter may have formed farther in and moved out. It's one of the possible theories, yeah. And when we observe Jupiter-type planets around other stars, we call them hot Jupiters because they're very close to the star, very close to the sun in our case. So they would form, about inside the inside the orbit of Mercury, something the size of Jupiter. But it's not going to crash into us on any kind of time scale that I am concerned about.
Again, too much television, asteroids, pieces of the planet that could break off and strike the Earth?
Because it's a gas giant, it's called a gas giant. That's a bit of a misnomer because even though it's made of what we think of as gas, hydrogen and helium, at those temperatures and pressures, it's really more of a liquid. So you're not going to break a piece off in the sense that you would sort of, smash something into another planet and break something off.
Okay, let me talk about the faith connection to this. And one of the reasons I asked David to be part of this panel tonight, how does faith and legend look at the planet Jupiter? Does it tie to faiths, and how has it gone through the history?
Each culture that has had a strong interest in astronomy, astronomical observation, these are the large civilizations that we have records for, each of the different civilizations, such as China, Babylonia, sort of eventually get to the Greeks, Romans, Egypt, Indian astronomers as well. Each of them had a different way of understanding, imagining, if you will, what this planet symbolized or meant. But there are some common astronomical features that would shape the way in which these different cultures would give interpretation to them. So help me if I'm right here, because it's big, and it's bright, second brightest to Venus, if that's correct. So if we sort of go back in time and imagine looking up into the heavens and seeing a big old bright thing doing a planetary motion pretty much 12 years all the way through the zodiac. And so a pretty regular orbit, or a pretty regular motion from a terrestrial perspective, and going through sort of the zodiacal figures regularly, so that more or less one per year, and close to the ecliptic. Is that all right? Wow, I don't understand anything that I just said, but they're nodding. That's good. What that means is you've got this big bright thing being very regular. And so within that imagination, you've got sort of strength, power, you've got regularity, you've got order, you've got structure. So it's quite natural from a Greco-Roman point of view that you would imagine this to be connected to Jupiter, and hence the sort of king of the gods, Father Jupiter. So this large sort of regular body that governs as a head patriarch of a deity family would be. In Babylonian culture, it was the figure was Marduk, who had earned the right to order the heavens, if I recall the mythology, through his defeat of Tiamat. And so again, this regular motion, different culture, still going to be associated with establishing some basic structure to the heavens, even though all the other planetary motions, I think, are much more irregular. Is that correct? And not as you would experience them as not as predictable with different retrograde motions. Is that correct?
Well, Jupiter was the farthest planet known to the ancients. Saturn wasn't discovered until the onset of telescopes, so it would have had the longest orbital period of all of the ones that they could see at the time.
Uranus. Saturn was known to the ancients, right?
Oh, sorry.
30 years.
Yes, one more out.
Yeah, one more out, one of those.
Was it Saturn and Uranus discovered in the last century along with Pluto, which I already know is not a planet anymore, right? 1930, I think, is when they thought they discovered Pluto, right?
Saturn we have for Saturday, and it's been around since antiquity, but Uranus, Neptune, and Pluto are all post-classical, post-antiquity planets.
Yeah. Okay. And then they released Pluto. They de-annexed it or whatever they did. Why was
2006, I was in Prague when the International Astronomical Union voted it out of the solar system. No, it's still in the solar system, but demoted it to a dwarf planet, but king of the Kuiper Belt, right? King of the icy.
Yeah, what does that mean? It's not like they get foreign aid. Or, what's that? Are those people like immigrants from another planet? I mean, I've never understood that. But just as a point of contrast, we know that Saturn, which is beyond Jupiter, has the rings. Are they made of ice? Are
Yes,
these
ice chunks, yep.
Yeah, we just had a talk on Friday night here in this room with one of the scientists that works on the Cassini mission, talking about what we know about the rings now at the end of 20 years of Cassini in space.
Oh,
But
share. What do we know?
A lot. Actually, this is an hour-long talk.
No, I mean,
Yeah.
can you, anything, is it water that has been frozen that could be used? Is it water that returns to the planet? What do we know about the rings?
Yeah, well, they're mostly ice and rock, and they're probably didn't form with the planet, but formed more recently, and they're maybe reproduced like a moon that was tidally disrupted. They're very small particles, like about the size of the people in this room, sort of floating around. The rings are only about the height of this room as well.
Okay.
But Jupiter, all the gas giants and ice giants have ring systems to some extent. Saturn's is just the most obvious.
Now, mind you, I am not a scientist. I know nothing. I'm just leading them through this conversation. When you talk about all the moons of Jupiter, what defines it as a moon? To me, they're so big they could be planets themselves. What's the difference for the lay part of the audience between a planet and a moon?
Well, the only definition really is that it is orbiting something that is orbiting the sun. So if you're orbiting the sun, you're a planet, unless you're Pluto, and you're a Kuiper Belt object. And if you're orbiting a planet, then you're a moon. So it's not a size discrepancy. We have moons of planets that are bigger than some of the planets.
Do we have moons to Jupiter that go way outside and come back? I mean, are their orbits all fairly close to the planet, or are there some that go outside and come back?
Well, yeah, so of the 64, the most distant ones must take years and, quite a long time to go around. They're definitely contained, basically there's Mars, the asteroid belt, and Jupiter, and those moons are tight up against Jupiter on that kind of scale. Otherwise, they'd be perturbed and go off into the asteroid belt. So they're probably, in fact, many of them, and one of those, this one right here. So it says retrograde and prograde irregular moons. So you can see most of them are going around Jupiter backwards, which speaks to where they came from. They were interlopers that got trapped in Jupiter's gravity well.
You can kind of get moons two different ways. You can either form them with the planet, or you can capture something coming in. And if you form with the planet, everything that's forming is kind of rotating in one direction. So you expect that those moons are going to orbit the planet in the same direction it rotates. And as we see for Jupiter, a lot of them go backwards. So it's more likely something that came in, and like a comet or an asteroid, protoplanetary kind of things that were captured.
Okay, we're going to take your questions from the audience. We have 2 microphones that's set up. We're going to go to you shortly, so think about your questions for our panel. I think it was Jason, and all 3 of you had an opinion on this, that mentioned about the fact that we sent an orbiter to Jupiter of some kind. It took a while to get there. How long did it take to get there, and did it actually go into the planet?
Yeah, so Jupiter's had 2 orbiters, Galileo and Juno. So Juno's there now, but Galileo left in 89 and arrived in 95, December 7th, 95. And right before it got there, weeks maybe, it released the probe, the Galileo probe, which went into the atmosphere. So that's the only time that a man-made spacecraft has entered the atmosphere of Jupiter. And when it did so, it was the fastest ever human-made object. It entered Jupiter at 175,000 kilometers an hour. And in just 2 minutes, it was down to hundreds of kilometers per hour with a neck-snapping 230 Gs.
Wow.
Deceleration. Yep.
Wow.
And it was able to measure the heat flow and the composition of helium and other elements. It was sniffing the clouds as it went through. It found less water than they expected. Went for a dry patch, it turns out. So that was very fantastic. And meanwhile, the spacecraft was right above it, the main spacecraft, ready to receive its signals and send the information back. So it was all over in less than an hour, but it spent about an hour before the Galileo spacecraft was no longer in radio contact with it. Also, it's busy melting because it's getting so hot down there.
So these things can't come back, obviously.
No. It's now blended. It's enriched slightly the metallicity of Jupiter.
Translation, space junk.
There's a lot of Galileos that we discuss here. Galileo the spacecraft, Galileo the probe, and Galileo the person. I mean, not that you are, but who discovered the moons and, gave us a lot of this information.
Do the 3 of you ever work together and have your classes merge, or have you ever done functions together? Because this is the second time we've done programs here, and you all, I mean, in the pregame interview, I didn't have to say anything because they were all chatty about Jupiter here. Why is Jupiter important for our audience listening on radio, watching on YouTube, and here tonight?
Well, Jupiter is the most massive planet in our solar system, as we discussed, but it really dominates all the orbital dynamics of our solar system. I mean, some textbooks even will describe our solar system as the sun, Jupiter, and the debris including Earth and all the other things. But you could do a pretty good model of the orbital dynamics of the solar system with just Jupiter and the sun, and then whatever your test particle is. It's, sculpted the asteroid belt. It's likely its formation sort of controlled the way the rest of the solar system formed, and it really dominates what we see in the solar system today.
I'll tell you why it's important. It saves fuel. So when the Galileo spacecraft we mentioned left in 89, got there in 95, by going by Venus and Earth twice, it saved 11,000 kilograms of fuel. That's 12 times more fuel than it would have needed if it would have went there straight.
Wow.
So the spacecraft fly by the planets and they get sort of an orbital
So
kick.
Jupiter saves us a lot of energy because all the spacecraft that go beyond Jupiter use Jupiter as a gravity assist along the way.
David, why is Jupiter important for all of us?
I think Jupiter is, we talked earlier about sort of that imagination of the heavens, and it's sort of a representation of the sort of ordering and the structure of the cosmos. And one of the things we were reflecting on these days, I guess, with the LIGO discoveries and all these ways in which the universe is sending out various gravitational waves, lots of explosions, lots of bing, bang, pow, kabloomy stuff. Do we think of the universe as this chaotic thing where things are ramming into each other and stuff is happening and expansion and contraction? Or is this back to that image of that, not a perfectly regular motion by a terrestrial standard, but do we have that image of the heavens that are ordered, that are structured, that give us a sense of calm and regularity in the cosmos, so that as we look up, we go, yes, there is order, yes, there's a hope for peace, or do we look up into the heavens and go, like we have to dodge? So I think from the imaginative point of view, I think that that's very important as we think about what does it mean to look into the heavens, what do we see, how do we imagine our place in this the space is pretty big, right? Yeah. Okay.
As Douglas Adams says, you might think it's a long way down the shop to the chemist, but that's just peanuts to space.
I think, Jason, you told us about a comet that crashed into Jupiter.
Yes.
Tell that story.
Shoemaker-Levy 9, I believe it was discovered in 1993, and it was unusual because it came in chunks. So it was originally a solid one comet, but it got a little bit too close to Jupiter, and Jupiter's gravitational field broke it into, an alphabet of pieces.
I think it was about 20.
20 pieces, right? And then shortly thereafter, it collided with the planet itself in the first major collision ever witnessed, at least a little bit indirectly, but certainly in our solar system. So we have evidence on the moon and the other planets of tremendous, even on the Earth, wiped out the dinosaurs, of tremendous collisions of asteroids and comets with bodies, but we'd never seen in human lifetime had seen a major impact. So that was a big deal. So I was a graduate student in Ohio, in Toledo, and got to see Jupiter the night that it was being hit by the comet. It was very exciting.
Is it true that somehow when the planet turned, you could see the damage like a bruise?
Yes,
like
we
on
have
a
some
piece
of the pictures
fruit?
you've been seeing up here, right? So the normal white clouds were darkened black by material that was churned up by the impacts.
What's the heat of the planet? Do we know? Does it vary? Is it a hot planet, cold planet?
It depends on, it's sort of how deep you can see. So sometimes there'll be patches where you can see. So it's definitely like all planets, like the Earth, the deeper you go, the warmer it gets. And since it's a big gassy planet with different amounts of clouds, you can see, the where you see deeper, you see hotter. So you'll see, if you, especially in the infrared images we're showing here, I think it's the next one, those lighter, so in the general band structure of Jupiter, where it's brighter is where you're able to see a little bit deeper into the planet, and the dark, blacker areas are the cooler outer layers. So you can actually, it's like using an infrared camera, you can put a little thermometer on each of those spots. So you'll have warm spots and cold spots.
For our panel, we just went through an eclipse here, or a total eclipse in August. Does that planet ever line itself to a point where we might see some kind of eclipse or see it daytime as big as that planet is, do we ever even get close enough or get to a point where we can see it with the naked eye? Probably not.
Yeah, you can see Jupiter with the naked eye. You would never have an eclipse, though, because Jupiter's orbit is outside the orbit of the Earth, so it would never come between the Earth and the Sun. Only things that are interior to the Earth's orbit will transit the Sun or the Moon, can move around and go in
So it's
front.
only the moon for us, no planets for an eclipse?
Well, Mercury and Venus both transit the Sun, and it was actually the transits of those that helped the early astronomers work out what the size of the solar system was. So they were very important to our understanding of.
You can, however, see the moons of Jupiter move in front of Jupiter's disk.
Ah, yes.
And in Sky and Telescope, they always keep you abreast every month of all the times that Io or Ganymede or Callisto or Europa would be moving in front, because you get the silhouetted disk. Sometimes you can see the moon and the moon's shadow at the same time. That's really spectacular.
And that's one of the things that David and I were discussing before this, because, Galileo the man, not the spacecraft now, when he discovered those moons, it really lent credibility to, these moons are actually orbiting Jupiter, and at the time, everything was supposed to be orbiting the Earth. That was our sort of place in the heavens. So, it actually became a bit of a religious argument. Should we be having a very, very literal interpretation of the Bible, or is it more a reflection on, the human condition? So his sort of discovery of those moons and realizing that they were orbiting Jupiter really changed things when people at the time thought everything was orbiting the Earth. So how are these moons orbiting Jupiter if everything's orbiting the Earth?
Europa is is it the largest moon? Is that how it's pronounced?
It's the fourth large, Ganymede's the largest, but it's probably the most interesting. It's
Because
the
it has
fourth.
all that ice.
It has all the ice, right? It's basically super, super smooth. So the whole surface differs by 600 feet or so, top to bottom. So the highest mountain or lowest valley is no different than 600 feet. So it's very smooth, super reflective because it's very icy. And when you look in detail with Galileo, the spacecraft's cameras, you can see ice flows that look a lot like ice flows in the Arctic on Earth. And that suggests the ice is moving around on fairly short time scales. So that means the crust is thin and it's likely atop a very large ocean. So we expect there's more water inside Europa than on all the water on Earth.
More ice, producing more water on Europa than the entire planet Earth.
Yes.
Wow.
So it's at the cost of bottled water. Just saying, for all those involved in commercial space operations. So
It's one of the places in the solar system where there's a potential for life. So that's the reason why at the end of Galileo, the spacecraft's mission, they had it plunge into the planet to destroy it, just to make sure it wouldn't crash into Europa and contaminate any life that could be there.
Does NASA or the private sector or the government have any idea of colonization, taking materials from the planet? Is there an interest? We don't have the technology or the ability to go, but somewhere in someone's mind, are they thinking, that's prime real estate?
Well, we do have the technology to go because they're planning missions right now that could get there in the 2020s if we really wanted to. Colonization, probably not, unless you're in a submarine, because the magnetic field and the particles there are just a huge radiation hazard. So spacecraft that are Galileo's time was limited because its electronics are sitting in the Jovian magnetosphere, which if you could see radio waves with your eyeballs, the magnetosphere would be 3 full moons wide on the sky. So Jupiter's this little tiny dot in the sky, but its magnetosphere, it is the king of the planets. It has a king of the planet size magnetosphere, and so it's enormous. And that's magnetic fields, accelerating particles to high velocities, and damaging spacecraft and humans if they were walking around on the ice. So it'd be a short visit.
I think you also said that if we were somehow standing on the planet, we would weigh or feel like we weigh twice what we weigh? Or is it
I think
more
it's
than
about
that?
2.5, but yeah, around
It's
that.
how many times?
About 2.5, around twice,
Okay.
yeah.
So,
Thanksgiving dinner,
Yeah,
after
yeah.
Thanksgiving dinner, yeah.
so you'd be like,
Post-Halloween candy, right?
get me off this planet. We're going to take questions next. If you would step down to the microphones, we'll have them, and we want you on record. So if you have a question or you want to make a comment about the planet, do so right now. Come down and join us to the microphones, and then we're going to have our band to sort of play us out at the end of the program while we continue. So the general public is welcome to ask their questions on the record because the radio audience is going to get to hear you as well. So please, come down. We have 2 microphones set up, and ask your question or make your comment. No question is being tossed aside. We just ask you to be brief. See, we have a volunteer already. And we have one of our players. So let's take from the left side. Why don't you give us your name and your field of study, what year you're in here at Embry-Riddle so the public knows.
I'm Brendan Kirkpatrick. I am studying AE and I'm a freshman. I would just like to know more about the big red dot on Jupiter.
Well, it's a giant storm system. It was observed by Galileo, the dude, the man, back in the day. So we know it's been existing probably as long as the planet has. I believe the spot itself is about 3 Earth diameters wide.
So it's at least 400 years old. So it's a major storm.
I mean, we thought Irma was bad, right?
Thank you. Over here now, your question. Good evening.
Good evening.
Oh, tell who you are, please. We ask all the students, so people will have been saying to us who are listening to this on radio, who are these people? Are these students from Embry-Riddle? So let's tell them.
My name is Christina Chu. I graduated with a degree in space physics and engineering physics from Embry-Riddle. My question is indirectly related to the magnetosphere of Jupiter.
Right into the mic, please.
You mentioned it had a very large magnetosphere, very strong, and so in that respect, it should be similar to Earth, which also has a magnetosphere, in causing aurora on the planet. So Jupiter, Saturn has hexagonal auroral pattern, and I was wondering if you could talk a little bit about Jupiter's auroral pattern.
It has aurora. What else do we know about it? We did not study up on the aurora. You're ahead of us. Christina's modest. She has a PhD in space physics, also from the University of Alaska Fairbanks, so she might know more about aurora than I do. So I know Juno doesn't have imaging cameras. It has a public outreach camera, so it may be able to study more, and it's got a polar orbit, so it's in a very good orbit to study aurora, potentially. And visible light camera, but the aurora that we see on Earth come from optical emission from oxygen and nitrogen, but maybe those aren't the abundant species. You look for hydrogen, maybe hydrogen alpha and ultraviolet lines is what you're saying? Perhaps? Yeah, I'm not sure.
It's possible. Okay, thank you.
Thank you. Over here, your question. Introduce yourself to our audience.
Hi, I'm Maria De La Quadra. I'm a freshman here at Embry-Riddle. I'm an aerospace engineering major with a focus on astronautics. My question is also about the aurora, so very sorry about that. Lately it came out on the news that Jupiter's auroras are not in the northern and southern tip. They're not pulsing at the same time. Can you tell us, going up, what that really means? For example, in Earth, if that were to happen, what does that mean necessarily?
Well, to talk about the formation aurora, these are charged particles either originating from the sun or perhaps even from sulfur ions from the moon, Io, which we haven't talked much about, but it's the most volcanically active body in the solar system. So it's contributing charged particles, and those charged particles are following the magnetic field lines into the atmosphere of Jupiter. And so when you talk about the auroras pulsing or changing, what you're really talking about is the precipitation of the particles. So something about the source of those particles is probably changing, right? Either the flux of, I imagine the flux of the solar wind is changing, the interplanetary interaction of the interplanetary field of those particles, or perhaps the volcanism that's contributing. So the volcanoes may be changing their rates, if that's a significant amount of the particles. So I'm just giving you things to think about. I'm not sure on why they're changing, but I think there's some connection there.
Going on, so
right.
I didn't really expect a clear answer. Thank you so much.
Yeah, sure. Yeah, it's hot off the presses.
Over here, good evening, and please introduce yourself.
Hi, my name is Sarah Murray. I'm studying computer engineering and I'm a freshman. I was just curious, like, how much stronger is Jupiter's gravitational field than Earth's, and does it have more? Does the mass of the planet or the size of the planet have more effect on the size of the field?
It's the mass. How much stronger is it than Earth?
I think it's 300 Earth masses.
Yeah.
But how much you weigh on the planet depends also on is a combination of how far you are away from the center and its mass. So even though it's 300 times more massive, you only weigh 2.5 times more because you're so much further from the center. So when you take your physics classes, you'll learn that the acceleration is proportional to the mass divided by the radius squared. So the further you are from the planet, the lower your acceleration toward the planet. So it depends on where you are on the effect, right? So Jupiter wins it's got a huge mass, but its effect is proportional to, how close you are to it.
And it's also, Jupiter's basically as big as a planet can be. The image they show in textbooks is the stacking up of pillows. If you stack some pillows up, they'll get higher and higher, but at some point the weight of the pillows start to press it down. So if you plot, how much more massive, or how much bigger in diameter so Jupiter would be if you added a lot more mass, the answer is about the same. And at some point it would start to get smaller because the mass just starts to compress itself. So Jupiter's kind of the sweet spot between having a ton of mass, but then still sort of a low gravitational effect on the surface because you're as far away as you can be from that mass.
Let's come over here now. Please introduce yourself and welcome to the Jupiter Experience.
Hi, I'm Abigail Johnson. I'm also a freshman aerospace engineering student here at Embry-Riddle. Since Jupiter is the closest gas giant to us, I was wondering, would it be a prime location for future space stations for redocking and refueling of future deep space missions?
Good question. Could it be possibly a space station?
Well, because it doesn't have a surface to land on, by the way, I like your NASA t-shirt. Because it doesn't have a surface to land on, it wouldn't in the sense that we sort of set up a base there, but presumably some of its moons could be. One of the reasons why we usually want to have sort of a base station along the way is because we're trying to escape the Earth's gravity. So one of the arguments for having a station on the moon is that we can launch from there and not spend all of our gas getting out of Earth's orbit. You sort of want a pit stop on the way. So Jupiter, because it's so massive, if you were to land there, it's very hard to get back off of the non-existent surface. So even one of the nearby moons, you would actually want to use it for a flyby, but then you want to land on something less massive. But presumably maybe the Jupiter Trojans, which are some asteroids that orbit ahead and behind of Jupiter in its orbit, but they're kind of far enough away, so you get that distance out into the solar system, but you don't get the sort of gravity-dominated trying to take off from the surface.
So could you possibly have a space station in orbit around Jupiter?
You could, but one of the places we like to put them are the Lagrangian points, and Jupiter's are filled up with these asteroids, the Trojan asteroids that orbit there. But yeah, presumably you still could put it in a stable orbit there. Yeah.
Thank you. Hey, I got a question before this gentleman come right up. Who gets to pick the names of the moons? Is there some sort of sanctioning body, the United Nations?
The same people that demoted Pluto. The International Astronomical Union.
They're the ones who pick the names?
Ashley?
I think, yeah.
You're in it?
Well, I was a junior member at some
Junior
point.
member, okay, yes. So we're voting members of the IU, and they have a naming committee. And so when they discover new objects, they go through a process. Or even, they've been busy with Pluto recently because they had the fantastic flyby last year of Pluto. And now they're officially sanctioning all the names of the craters and regions on Pluto. So they're a busy group.
So if I flood this body with members, we can get a new vote for Pluto and bring it back. Yeah. Am I hearing this? Okay, I just,
Start lobbying now.
Okay,
Sometimes we hear about a sea on a moon or a planet. What determines, since it's not like a sea in the traditional sense that we know them, what determines a sea? Is it an impression in the planet?
You mean like a ponding of water? Most of the water that we know about on planets are like subsurface oceans, so kind of underground.
But I've heard things referred to as seas, and there's no water
Certainly
there.
there's, on the moon Titan of Saturn, it has liquid methane, actual lakes.
Yeah.
Wow.
And rain.
So on the moon there are oceans and seas, and that was just from the language of Galileo, who saw smooth regions and mountainous regions, and so he called them the mare or maria in plural as seas. But now we know that they might have been liquid 4 billion years ago when they were lava, but they are no longer. But there actually are liquid, I guess the only place in the solar system besides Earth with liquid on the surface.
Okay.
Substantial amounts of it is the moon Titan.
By the way, this, oh, go ahead, Dave.
Oh, no, I was just going to say about the naming and the moons, that there's, whether it's providence, divine ordering, random chance, Jupiter was, how should we say, in Greek and Roman mythology, got around. And so the 64 moons, I'm not sure if all was named for one of his paramours, but there were quite a number. And so in Greek mythology, Jupiter or Jove or Zeus is the father of many gods and heroes. And so all the 60, I'm not sure if are all the 64 named after
Certainly
a romance?
the big four are part of the classic story. And that's why NASA named the current mission Juno, because Juno, the wife of Jupiter, lifted the veil to see what was going on. And Juno, the mission, is lifting the veil on our knowledge of the interior of Jupiter. So very clever.
Your question, good evening. Please introduce yourself and welcome to the Jupiter Experience.
Hi, my name is Chase Cavello. I'm a sophomore studying spaceflight operations, and I was wondering if you could talk a bit about the core of Jupiter, what it's made of, and is metallic hydrogen in play?
So we don't know as much about the core of Jupiter as we'd like. I mean, one of the recent results that's just come out of the Juno mission, which is there now, is that it's a lot sort of fluffier than we thought. So we have some idea of what the mass is, but not how far it extends. You see these images in your textbook where you've taken a triangle slice out of the planet, but where that sort of line falls is quite hard to determine, and that's one of the things that Jupiter's trying to answer, maybe you could say.
Yeah, and just so there's probably this inner region is rocky, icy, and then transitions into more hydrogen dominated. But at those high pressures, the hydrogen is liquid, as we mentioned before, or this metallic hydrogen. So so you go through as the pressure drops as you go outward, it transitions from these intricate liquid phases eventually into gas phases. So it goes gas, liquid, and then solid. And Juno is really going to tell us the distribution of mass as a function of radius in the planet. That's going to be very exciting.
Very cool, thank you.
Okay, across the way, good evening and welcome.
Hi, my name is Adam Milsim. I am a junior at Embry-Riddle, and I study global conflict studies. And I'm going to commit blasphemy because I'm not going to ask a science question. I'd just like it if y'all could discuss a little bit about how Jupiter's status of cultural importance has changed since its discovery with Galileo up to now.
Well, I think starting with the Galileo piece and sort of the reimagination of what's the center of things. Is it the Earth? Is it the Sun? Or is it a different understanding of the universe? I think that Jupiter had for many centuries before and after Galileo and into the sort of probably declining the last couple hundred years, the connection to astrology and sort of the astrological imagination. That's something that Brian Herget was talking about earlier. And so the notion that the planetary bodies in the heavens influence human behavior, human action, to be born under the sign of Jupiter was a sign that you would have what's called a sanguine disposition, much more happy, much more optimistic. And so, as Brian was saying, the subtitle for Jupiter is the bringer of jollity, happiness. We might think, or sort of frivolity. The word Jupiter, another name for Jupiter is Jove, and we get the word jovial. And so, in that imagination, Jupiter/Jove. To be born in that under the sign of Jupiter, under the sign of Jove, is to have a jovial personality. And within that, the notion that we are connected to the planets would make perfect sense in going Greek understanding of the humors. And so Jupiter and Jove would govern the blood, which is the sanguine, you might imagine, sort of the sanguine personality type. So for several, many centuries, there's this connection between heavens and the earth, heavens and individual persons. Going all the way back to the Greeks with the humoral understanding, the humors within the body, the different bodily fluids being governed. So up through Galileo and into probably 18th, 19th century, you've got a strong emphasis on sort of the role, for many people, not all obviously, strong notion that the observations of the planets connects to human identity in a way. That changes dramatically. I'm not sure exactly when that just starts falling off to the point at which we lose that connection. Now I think some of the exciting things that people are raising questions about, sort of exploring, discovering, sort of missions. So it's gone from an influencer to something we might go to, sort of an object for study, a place to land. And I think that'd be stuff off the top of my head. How about you guys in terms of?
I was thinking specifically about the cultural link between the Babylonians and the scientific work of the Greeks, just because the Babylonians had an ecclesiastical reason to observe Jupiter, and so they made exquisitely regular observations of it all the time, and that database of Jupiter observations fed into the early Greek science, and they were thinking about the bigger picture. They wanted to make models for everything, and this was the data set that was handed to them by the Babylonians. So it doesn't really matter why they were taking that data. The fact that they took it was very useful. And the Babylonians, we now know from contemporary, just recent work on the tablets, we know that they were doing a little bit of calculus, trying to figure out if it's important where Jupiter is when someone's born. They want to be able to predict ahead of time, when will Jupiter be next to that star? So they're doing a little bit of integrating under the curve, for those of you in calculus, to try to figure out where Jupiter would be. So they were doing some pretty interesting math we're now learning more about.
And I think, just one other thing, for Chinese culture, the Chinese system of 12 animals and 12 different years that rotate, I believe that's connected to the Jupiter's motion through the different constellations, imagined differently, not ours. And so within Chinese imagination, Jupiter again has that regulatory function, sort of setting the more or less a structure for this 12-year cycle of repeating of the different animals. And again, connection depending on the year of which where Jupiter, if I recall correctly, if the Jupiter's in the house of the monkey or the realm of the monkey, that's the year of the monkey, and so on and so forth. And so in that sense, again, within that imagination, the planet is again exerting an influence within those kids born in the year of the monkey or whatever it is.
Let's come over here. And your question, please introduce yourself to our audience.
Hello, I'm Jackson Smith. I'm a senior aerospace engineering student. And my question is, since you mentioned that Jupiter is such a big influence in the solar system, I mean, you can approximate as a restricted three-body problem and ignore everything else. What effect, if any, does it have on our satellites, both in orbit around the Earth and possible orbiters around Mars?
Well, it's going to have a small effect, but still an important effect, especially if you look at it over really long periods of time. So Jupiter can cause, like nodal precession and small effects like that. So it's more just sort of balancing all the gravitational forces and keeping up with everything, but it would be more of a long-term effect. I mean, you look at the asteroid belt, for example, why does it have the edges it has? Pretty much because of Jupiter's effect on the long term on those orbits. There's giant holes in the asteroid belt where there's no asteroids because they're in a mean motion resonance with Jupiter, and it causes their eccentricities to pump up, and so they get kicked out, possibly become Earth crossing, possibly become Earth impacting, So that could actually even be a mechanism by which water was originally brought to the Earth. We don't know, it's speculation. But yeah, so it's a small effect, but it's important if you're interested on things on long time scales or specific time scales.
Thank you.
Let's come back over here and your question now.
Hello, I'm Fabian.
Right into the microphone, please.
Hello, I'm Fabian, and I'm a freshman aerospace engineering student here at Embry-Riddle. I've actually got two questions, essentially.
Need to be a little closer.
Okay, sorry. So how does something that big just form, like in the middle? Like it was said, like it was believed to be formed like in the near of the sun. Like how does something that big just form there, seeing that the sun just likes to burn everything away?
Well, we don't know for sure. I didn't mean to imply that Jupiter necessarily formed near the sun. We see what we call hot Jupiters, which are bodies the size of Jupiter, but really close to their stars when we observe extrasolar planets. But there's other sort of orbital mechanisms, like the Kozai mechanism, by which those planets could have formed outward and moved in. And we don't really know the exact order in which the planets formed. There's lots of different models you can create where you have things move around, and they explain things such as like the bombardment of impacts that created all the craters on the moon. And there is one that has Jupiter sort of forming farther in or forming out and moving around. But how does it get so big? When the solar system is forming, you've got the whole solar nebula and everything spinning. And as you start to grow, it's like a selection effect. The bigger you get, the more mass you have to draw in more. So the gas giants were able to, draw in just a lot more of the mass of this forming cloud than the terrestrial planets were. So they sort of Jupiter just hogged it all, basically.
It has something to do with the sweet spot, right? Because it has to be far enough out that it can be cold enough that some of those elements can condense. Like it's just too warm on the inside. It's all the metals are like melting on the inside. And there's some density fall off of the solar nebula. So if you're too far out, you just don't have enough to collect. And if you're too far in, things are just too hot. So Jupiter's kind of in that sweet spot where it can still have enough of the solar nebula to grab once it gets big enough to be greedy. And it's far enough out that it's cool enough that so if it's too hot, all the particles are just whizzing around. The gas is too hot; it won't be gravitationally bound. So it's
And exactly where that sweet spot is a function of the star that the planets are forming around. So there'd be a certain sweet spot for our star, and maybe a different one for the extrasolar systems as well.
You have a quick follow-up? Did you have a follow-up question?
Oh yes, I had a unrelated. It was a different question.
Okay, go ahead.
Slightly less plausible question, but like, what would happen like if? Not what would happen. Like, how feasible would it be? Like, I know it's made of a bunch of gas, similar. I've heard that it had a similar makeup to the sun. Like, how feasible would it be to just randomly some random event causing fusion to start?
Well, Jupiter's, I think it's made up of the same things that the sun is, hydrogen and helium, because it formed out of the same cloud, but it just didn't really get massive enough. And I think it needs to be, is it 80 or 800 times more massive than it is? Maybe 80 times more massive to have actually started fusion and become a star. But one of the reasons why Jupiter has a lot of moons and stuff is because it almost is a little mini solar system where Jupiter's almost a star, and then it had its own sort of circulating cloud that produced all these moons in the same way that the sun's cloud produced the planets. But it's just not quite big enough.
Yeah, you just need high temperatures and pressures to convince the two protons in the star are charged particles and they naturally repel each other. So you got to overcome this incredible barrier of like-charged particles to fuse, and that requires tremendous pressures and temperatures, so much larger masses. So the center of the sun is tens of millions of degrees, and so you need to get to those kind of temperatures, and you don't get there without a lot more mass.
We have time for 2 more questions, and then we're going to ask the band to reassemble here. Your question now.
Hello, I'm Sean Reid. I'm a freshman aerospace engineering student here at Embry-Riddle. My question regards Europa. Is it theoretically possible for humans to actually colonize that planet, or is it too highly irradiated / not in the Goldilocks zone to be colonizable?
I definitely think there are challenges with the radiation field for sure. That doesn't mean you can't cut a hole on the ice and take your submarine down there.
If you like cold weather.
If you don't like light. So it's not the best place. I mean, maybe if you bring your lead house with you, so it's challenging. Even Mars is challenging from a radiation standpoint, but nothing like Jupiter. I mean, Jupiter, the time period which spacecraft can exist in that inner part of Jupiter is really limited by the radiation field. So, I mean, it might be easier than Venus, but not a lot.
Thank you.
And we have one more question from the audience, and then we'll ask the orchestra band, the Pep Band, to reassemble. Go ahead. Good evening.
Hello, my name is Desiree. I'm studying aerospace engineering, and I'm a freshman. I actually had 2 questions. The first one's about Europa. How deep is the crust of Europa? Like, what's an estimation of the depth of the crust?
Yeah, I think it's no more than several hundred kilometers, I think, or
That's reasonable.
Yeah, so it's it's about the size of our moon, but it really isn't that deep. So of the whole, say it's several thousand kilometers in radius, but only a couple hundred kilometers thick. So it's only the last 10%, only the outer 10% or so is the crust, and the rest is, and it probably has a rocky. It's differentiated for sure. In other words, the metals and the heavy rocks sunk to the bottom, and the lighter water and ice are on the outside. But we need, there are missions that are being proposed right now and being reviewed by review panels right now for another flyby, a lander. Europa is a hot topic, and it's easier to get to than Enceladus, which is the also icy moon that's very active, but it's twice as close. So it'll probably get the first attention.
Your follow-up?
I had another question, and which of the 4 moons are the closest to Jupiter, and does that factor into why Io is more volcanic and volatile?
Yeah, so Io is the closest of the 4 moons, and the reason why it has the crazy volcanism that it has is because of tidal effects. So the same kind of effects that we see the moon tugging on the Earth that creates the ocean tides that we see here. Io's in one-to-one spin orbit coupling with Jupiter, and it's very close. So it always has one face facing the planet. So whereas the Earth is turning, and we have high tide sometimes and low tide sometimes, Jupiter's getting tugged on in exactly the same way. And it's also on, I believe, an eccentric orbit, is it slightly? So there's different parts of the orbit where the amount that it tugs on changes, and you basically just stretching a rubber band over and over, you're going to heat it up. And so that's why it's become so hot, even though it's way out in the outer solar system and very cold, presumably. Right before Galileo was going to do a flyby of Io, some scientists published a paper saying Io's going to have all these volcanoes on it just because they'd done the calculations of the tidal effects. And everybody was like, no, it's freezing cold out there. And then Io flew by and they saw all the volcanoes, and it was a very exciting result. Like front page of the New York Times.
And Europa plays a role because it goes around, its period is twice the period of Io, right?
Yeah.
So Io might get out of this synchronicity with Jupiter if it weren't for Europa keeping it in line by going around exactly once for every time Io goes around twice.
Thank you. If we can have the band come up. Great questions from the audience. Give yourselves a round of applause. Don't go away. Don't go away. While the band assembles, and Brian, great job of putting this whole thing together tonight. Our compliments. Let's tell you about what we're going to do in a week when the Embry-Riddle Speaker Series resumes. When we come back, 1 week from tonight, aircraft cybersecurity. Dr. Robert Hickey, who is the Aviation Security Manager with the Department of Homeland Security, will discuss issues surrounding aircraft cybersecurity. We'll do a Q&A session as well. Students, you want to come for this, and the general public wondering how safe are we in the skies? We'll ask a person who will have to answer the big question. That's coming up 1 week from tonight. Ladies and gentlemen, once again, I want to thank our panel for being with us. Don't leave just yet. Jason Oftenberg, along with Ashley Kehoe and Reverend David Keck. Thank you all for doing this tonight. Round of applause for them, please. And to play us out, and we wish you a very pleasant evening, Brian now leads the Pep Band to play out on the Jupiter Experience. Have a very pleasant evening.